In the intricate calculus of modern warfare, where victory is measured in microseconds and determined by the integrity of a data packet, the notion of a singular, decisive weapon has become an anachronism. The contemporary battlefield is not a contest of platforms, but of systems. Every bolt, every composite panel, and every line of code is a component in a sprawling, interconnected organism whose resilience and reaction time dictate the outcome. It is a conflict where the primary target is not the enemy's armor, but their awareness. Within this paradigm, the command, control, communications, computers, intelligence, surveillance, and reconnaissance (C4ISR) architecture of a military force is not merely an asset, it is its central nervous system. For the People's Liberation Army, PLA of China, the construction of this digital nervous system has been the single most defining project of its 21st century modernization. A colossal undertaking designed to transform a force once defined by mass into one. This is the story of that system. A web of airborne eyes, stealthy nerve endings, and armored fists, all bound together by a philosophy that seeks to render an adversary deaf, dumb, and blind before the first shot is even fired. The PLA's journey from a doctrine of people's war to one of informatized local wars represents a fundamental shift in military thinking, where the network is the strategy and the hardware merely serves the network. This transformation is not merely technological, but deeply philosophical, rooted in a doctrinal evolution from informatization to the nascent concept of intelligentization. The initial phase, informatization, was a direct and candid emulation of the network-centric warfare playbook pioneered by the United States military, a lesson learned with brutal. In the PLA's own doctrinal texts, information power is explicitly ranked as the foremost element of campaign power, eclipsing even traditional metrics like firepower and maneuver. The objective is unambiguous: achieve information dominance by attacking an adversary's C4ISR architecture first, thereby paralyzing their ability to coordinate a response before picking off their disconnected forces with long-range precision fires. This is not an asymmetric strategy. It is a direct mirror of the American way of war, a case of learning from the master in order to one day defeat them. Yet, where the PLA seeks to diverge and potentially leapfrog its progenitor is in the next phase, intelligentized warfare. This concept is the high-octane fuel for the informatized engine, envisioning the deep integration of artificial intelligence, big data, quantum computing, and autonomous systems at every level of warfare. In this paradigm, AI is not simply a tool for automation, but a collaborative partner in decision-making. PLA strategists write of human-machine collaborative decision-making, where AI functions as a digital staff officer, capable of processing vast data sets and accelerating the observe, orient, decide, act (OODA) loop to a speed that transcends human cognitive limits. This ambition, however, reveals a deep-seated tension within the PLA's command culture. The very concept of intelligentized warfare necessitates a degree of delegated authority to autonomous systems, a requirement that runs directly counter to the Chinese Communist Party's rigid, top-down, and deeply centralized control structure. The ongoing debate within Chinese military circles over the ultimate role of AI, whether it remains a subordinate tool or eventually replaces human commanders in a battle space too complex and rapid for biological minds, is not merely a technical discussion, but a reflection of this profound political. To the casual observer, the aircraft is a near-perfect facsimile of the American Northrop Grumman E-2 Hawkeye, a piece of engineering so derivative it borders on dry parody. It features the same high-wing twin-turboprop configuration, the same distinctive quad-fin tail designed for stability in the turbulent air behind a carrier, and the same aft-folding wings essential for the claustrophobic confines of a hangar bay. This resemblance is not a failure of imagination, but a display of cold pragmatism. Why reinvent a design that has been proven effective for over half a century? Constructed by the Xi'an Aircraft Industrial Corporation, the KJ-600 is a substantial machine with a length of 18.14 meters, a wingspan of 25 meters, and a maximum takeoff weight of approximately 30,500 kilo. It is powered by two Zhuzhou Wojiang 6C, but the airframe, for all its utility, is merely the vessel. The heart of the KJ-600 is housed within the large, rotating dorsal radome. This structure contains what is widely believed to be the KLC-7 Active Electronically Scanned Array, AESA, radar, a sophisticated system developed by the 14th Institute of the China Electronics Technology Group Corporation, CETC. Unlike its land-based cousins, such as the KJ-500, with its fixed three-sided array for static 360-degree coverage, the KJ-600 appears to use a single-sided AESA antenna that mechanically rotates within the dome. This design choice is a trade-off, sacrificing constant all-around surveillance for a much larger and therefore more powerful radar array. Its primary mission, stated explicitly in analytical circles, is the detection of low-observable fifth-generation aircraft, like the American F-22 and F-35, at tactically significant ranges. Operating in the L or UHF frequency bands, which are optimal for long-range air search, this radar pushes a carrier strike group's sensor horizon out by hundreds of kilometers, transforming it from a coastal defense flotilla into a true blue water power projection instrument. Without the KJ-600, a carrier like the new Type 003 Fujian is half-blind, its vision limited by the curvature of the Earth. With it, the carrier group becomes a viable, independent offensive force, capable of operating with confidence deep into the Pacific. If the KJ-600 is the all-seeing eye of the fleet, the Chengdu J-20 Mighty Dragon is the stealthy, penetrating nerve ending of the PLA's C4ISR system. Far more than a traditional air superiority fighter, the J-20 is designed from the ground up to function as a forward intelligence, surveillance, reconnaissance, and command and control node, a ghost in the machine capable of slipping through enemy defenses to guide the weapons of others. Its physical form is a masterclass in low observable design, featuring a long blended fuselage, a canard delta wing configuration for high-altitude agility, and chiseled diverterless supersonic inlets, DSI, that mask the highly reflective engine fan blades from radar. Its primary sensor is a large ESA radar housed in the nose, estimated to contain between 2,000 and 2,200 transmit-receive modules, a density that, if correct, could give it a detection range advantage over its American counterparts. This is complemented by a suite of passive sensors designed for silent observation, a chin-mounted electro-optical targeting system, EOTS, for high-resolution imaging, and a 360-degree distributed. The addition of a second crew member is a tacit admission by the PLA of a critical reality in fifth-generation warfare. The sheer volume of data can overwhelm a single pilot whose primary focus must remain on flying the aircraft. The backseater functions as a dedicated battle manager or weapon systems officer, WSO, tasked with interpreting sensor data, managing the sophisticated electronic warfare suite, and most importantly, commanding formations of unmanned loyal wingman drones such as the stealthy Hongdu GJ-11 that will fly in concert with the manned fighter. This human-centric solution to a data saturation problem suggests that the PLA's automation and AI are not yet mature enough to fully unburden the pilot, representing a pragmatic but potentially transitional step on the path to true intelligentized warfare. The operationalization of these platforms creates kill chains of unprecedented length and complexity. Consider a scenario where the J-20 acts as a pointing finger for the PLA rocket force, PLA-RF. Leveraging its stealth characteristics, a J-20 penetrates a heavily defended anti-access area denial, A2-AD zone, The pilot, flying in complete electronic silence, relies entirely on the passive EOTS and DAS sensors to scan the ground below. The system detects and identifies a high-value, time-sensitive target, a mobile transporter erector launcher for a ballistic missile, for instance, or a forward command post. The J-20's mission computers instantly generate a precise targeting solution, coordinates, elevation, and positive identification. This data package is then encrypted and compressed, transmitted in a short burst via a secure, low probability of intercept, LPI data link designed to be indistinguishable from background noise. The signal is relayed, perhaps through a constellation of military satellites or another airborne asset, loitering safely outside the threat envelope, to a PLARF command center hundreds or even thousands of kilometers away. There, the targeting data is received and fed into the fire control system of a DF-17 hypersonic glide. Within minutes, a weapon is launched from far beyond the horizon, streaking towards a target that never knew it was being watched. The J-20 in this role weaponizes its stealth not for its own survival or to deliver its own internal payload, but as an offensive ISR tool that enables the PLA's most strategic conventional assets. Its greatest value is not the missiles it carries, but the data it can collect and transmit, solving the critical sensor-to-shooter problem that is the Achilles heel of any long-range strike system. This intricate weaving of the battle space extends from the strategic to the tactical, linking air and ground forces into a single, cohesive network. Imagine a KJ-600 orbiting on station over the East China Sea. Its powerful AESA radar sweeps a vast volume of space, detecting a formation of inbound hostile aircraft and several surface vessels moving at speed. The crew of 5 to 6 operators aboard the KJ-600 work to process this raw data, classifying the contacts, predicting their vectors, and building a comprehensive Common Operational Picture, COP, of the unfolding situation. This COP is not kept in isolation. It is immediately broadcast across the battle space using a high-bandwidth, jam-resistant tactical data link. This is the domain of systems like the PLA's Tri-Service Tactical Information Distribution System, TIS, an analog to the ubiquitous Western Link 16, or its more advanced successor, the DTS-03, which reportedly offers higher data rates and lower latency through the use of ad hoc mesh networking technology. Miles away, operating near the coast, the commander of the Type 99A, a 58-ton beast of steel and composite armor, is more than just a gun platform. It is a fully integrated node in this C4ISR network. Its onboard battle management system, fed by UHF-VHF radios, encrypted laser communications, and a Beidou satellite positioning system, decodes the data stream from the KJ-600. On the commander's digital map interface, new icons blink into existence, blue for friendly, red for hostile, representing the aircraft and ships detected by the KJ-600, assets that are hundreds of kilometers away and far beyond the detection range of the tank's own thermal sights or millimeter wave radar. The tank commander, sitting inside a steel turret, now possesses a God's eye view of the operational environment, a level of situational awareness previously reserved for a theater-level headquarters. This direct data flow from a naval aviation asset to an Army ground asset is the very essence of the PLA's concept of multi-domain precision warfare, MDPW, a concerted effort to break down the traditional. As the Type 99A tanks maneuver, a supporting infantry platoon deploys its own organic ISR asset. Back inside the turret of the Type 99A, the commander sees a new icon flash onto their battle management display, a hostile infantry symbol pinpointing the ATGM team's location just 500 meters away. This tactical-level data is now fused and overlaid with the strategic-level data from the KJ-600. On a single screen, the commander can see both the inbound enemy strike aircraft 200 kilometers out at sea and the immediate, lethal threat just down the street. The tank operator is no longer just a tanker. They are a fully networked combatant, making faster, better-informed decisions based on a complete understanding of both their immediate surroundings and the broader operational context. This ambitious vision places the PLA in direct competition with the United States' own concept of Joint All-Domain Command and Control, JADC2, a Pentagon-wide effort to create a Connect Everything Everywhere military internet. The PLA's MDPW is, for all intents and purposes, China's version of JADC2, sharing the same fundamental goal: to sense, make sense, and act across all domains at the speed of relevance. Both approaches rely on a similar technological toolkit of artificial intelligence, resilient mesh networks, vast satellite constellations, and advanced, low probability of intercept data links. However, beneath this technological convergence lies a stark divergence in organizational philosophy, a reflection of their respective political systems. The American JADC2 model, at least in theory, aims to push data processing and decision-making authority down to the tactical edge, empowering the individual warfighter with the information and autonomy to act on their own initiative. The PLA's system is a mirror image, rigidly centralized and unapologetically top-down. The Central Military Commission and the theater commands are the undisputed brains of the operation, maintaining tight, granular control over forces in the field. In a potential conflict in the Indo-Pacific, the PLA also enjoys a significant home field advantage. Its C4ISR network is not an expeditionary system that must be deployed. It is a permanent fortress built upon a vast, hardened, and redundant backbone of buried terrestrial fiber optic cables, providing a level of bandwidth and security that a deployed U.S. force would struggle. The PLA is betting on centralized control and systemic resilience, believing it can protect its core command nodes and win through superior top-down orchestration. The United States, conversely, is developing concepts like disaggregated collaborative air operations, DCAO, which plan for forces to fight effectively even when disconnected from the main network, viewing the PLA's centralized brain as a critical single point of failure. The competition is thus not merely about whose technology is better, but about which organizational model, the distributed network or the centralized fortress, is more resilient to the fog and friction of high-intensity warfare. In synthesizing this vast and complex architecture, one cannot help but be impressed by the system's greatest strength. Its intricate, centralized networking is also its most profound vulnerability. The over-centralization of command and control creates critical single points of failure. A successful kinetic or cyber strike against a theater command headquarters or the CMC's Joint Operations Command Center in Beijing could decapitate the nervous system, leaving vast formations of highly capable platforms directionless and paralyzed. Furthermore, the entire edifice is built on a foundation that contains foreign materials. The PLA remains critically dependent on imported high-end microelectronics and semiconductors for its advanced computing and sensor systems, creating a supply chain vulnerability that could be ruthlessly exploited through sanctions in any conflict that extends beyond a few weeks. The network's heavy reliance on a burgeoning but fragile satellite architecture for beyond line-of-sight communications and intelligence presents another glaring weakness. Satellites are predictable, fragile, and screamingly obvious targets for a peer adversary with anti-satellite weapons, jammers, and sophisticated cyber capabilities. But the most significant vulnerability of all is that this entire complex, delicate, and interconnected system of systems has never been tested. It has been paraded, exercised in highly scripted environments, and lauded in doctrinal papers. But it has never faced the crucible of high-intensity combat against a peer adversary capable of actively attacking every node and link within it. For all its impressive specifications, it may still require a ritual dance to start up. The PLA's C4ISR architecture is, in essence, a glass cannon. It has been meticulously designed for maximum information dominance and offensive power in a short, decisive, informatized local war. It is built to deliver a single, paralyzing blow. Should that initial strike fail, or should the conflict evolve into a protracted war of attrition, the system's inherent brittleness, its dependencies, and its rigid command structure could cause it to shatter, turning its greatest strength into its most catastrophic failure. The PLA's digital nervous system has matured at an astonishing rate, but its true resilience remains the most critical and unanswered question in modern military analysis.